All right, this is the weekly challenge for the week of February 15th, 2021. This is challenge number 1. So we're tasked with implementing this function encode, which is going to take a sequence of genes, which will be of the form of just a string with characters A, C, T, and G. And we're going to convert that string into a binary sequence, essentially, using these 2-bit binary numbers to represent these 4 possible letters. So it might look like we're kind of doubling the amount of information needed to store these letters, but in actuality, in order to actually represent the character A in a computer, you need 8 bits. So, since we know our sort of, if you will, alphabet is constrained to just A, C, T, and G, we can use a much smaller number system to represent those letters. So here we're using 2-bit binary numbers. If you don't know how binary works, highly recommend just familiarizing yourself with the basics. This is a very interesting number system, and of course it's intrinsic to computing and programming, and it's something that you really should spend some time getting to know. Right, back to the interesting stuff here. So we're essentially taking something that takes 8 bits to represent in a computer and reducing it down to a footprint of only 2 bits. So that's a memory savings of 4 times essentially. And when you're dealing with genetic data, that's billions of pieces of data. So this is a pretty huge savings in memory. All right, so let's get to the fun stuff. Let's actually start working on this function. So we're defining this function encode. I'm just going to give it the parameter genes, which is just that sequence, that string sequence. And basically what we need to do is go character by character in the string and convert it to whatever we have determined should be its binary representation. And then, returning that new string. So we're accumulating, right? So we're going to, initialize our accumulator variable. It's going to be an empty string. And what we're going to do is we're going to iterate over all of the characters and genes and then just concatenate onto this result string. Let's say for, element in genes. All right, so genes is a string. That means it's an iterable sequence, and so we can iterate over it directly. So for elem in genes means that each iteration elem is going to take on a single character from this string here, from any of these input strings. And so what we want to do is basically say, well, if elem is an A, we'll convert it into a 0, 0. If it's a C, convert it to 0, 1, and so on and so forth. So this is like the most basic pattern we can think of. So if elem is equal to A, we will concatenate 0, 0. And if it's C, we'll concatenate its binary representation, which was 0, 1. Oops. If it's T, that should be a 1, 0. And otherwise, it'll be a 1, 1. And so, we're going character by character through the gene string and checking if it's an A, a C, a T, or a something else, and converting it to the requisite binary representation. And we're accumulating or concatenating into an empty string to start, and we'll end up with our converted string. Now, real quick, I want to just mention, because we're using else here, it basically means if we get any other character, we're going to convert it to 1, 1. So we're kind of assuming here that our genes object or our string here is only containing the characters A, C, T, and G. If we get a string that has an X in it, it's going to be converted to 1, 1, even though that's not correct, because everything else is going to be caught by this general sort of otherwise do this statement that closes out this branch or this conditional statement here. So, you want to be careful if you don't necessarily know that your data is going to be clean. You might want to build in some sort of error correction or whatever you want to do. But for the purposes of this challenge, we're giving you, perfect input for your for the unit tests that test your solutions on Learn. We're just trying to keep it simple here. Boil it down to the core logic. So yeah, all it is a single branching statement that just checks which character it is and maps it to the to its corresponding binary representation. All right, so I have some test cases here. Let's just make sure that we have the correct output. All right, 0, 0, 0, 1, 0, 0, 1, 0, 1, 1. Yeah, that looks good to me. Other one looks good to me. All right, so this solution is okay. It's a little bit ugly, right? There's nothing wrong with this solution. It works, but this big if, elif, else, pretty long branching statements like this are kind of awful to read, and they're awful to write too. It's really tedious to write all of this, and it can be kind of a pain to read through all of that. And so there is a much better data structure that we can use to kind of do all of this for us, and that's the dictionary, Python's built-in dictionary type. So I'm going to make a dictionary called translator. And I'm just going to populate this translator dictionary with all of the character mappings that we're doing here. And that's 1, 1. All right, so this is a dictionary containing all of the information we need in order to make a translation between a gene string to a binary sequence. And then we don't need to do any if statements. No conditional checks at all are required. We can simply concatenate the result from translator elem, where elem is the key. It's coming from genes, so it's going to be either an A, a C, a T, or a G. So we will access this dictionary with that key, and it's going to return its corresponding binary number. And then so we've gotten rid of all of that, and we can see we have the same result. And yeah, that's a lot cleaner, right? That's a much nicer solution. It's making use of Python's arguably most powerful data structure, the dictionary. It's a pretty incredible data structure with a lot of really nice properties. Yeah, so that's kind of the sort of intermediate solution. I'm going to show another solution, actually. We'll go ahead and just comment all of that out. Actually, I'm going to keep everything. Let's comment that out. Whoops, don't want to comment out the function itself. All right. Okay, well, this is too hard to read. I'm going to delete all that. Okay, so the other method that I'm going to show, actually, I'm going to show three more methods. And I'm kind of getting more and more advanced with these solutions here. Obviously, like I'm just showing the same solution or solutions to the same challenge here. So, you can close the video if you don't care. But if you do care, if you want to see how to do things more interestingly or more faster, yeah, stick with it. So this next method I'm going to use is called method chaining. So we know, actually I'm going to jump into a REPL here, Python. I'm going to say s is equal to the string hello world. All right, so there's this method called replace. And it's pretty straightforward. It takes a string and replaces it with another string, and this entire method returns a new string. And that's because strings are immutable objects. Don't dwell on the details. You can read all about this and learn. But the basic idea is that this method s.replace is returning a brand new string. So this string right here that printed to the console is not s. S is still hello world, but s.replace ox is this new string right here. And replace actually also works on like substrings. So if I only wanted to replace this O with an X, I can do this. And actually, sorry, I should specify that it's also going to get rid of that L. So maybe if I wanted to do this. All right. So what I can do also is replace, or rather chain another replace call on top of this, right? Because this piece of code right here is returning a string object, which means, I can call replace on that resulting string object. So this whole thing boils down to a string, and then you can just call replace again immediately. So I don't know, let's say that. And now we're getting into some weird language here. But that's a very strong concept in object-oriented programming, this idea of chaining methods together. And you can only do this, when you have a method that returns an object of the same type, right? If I did, here's another string method, which asks for the count of the character O in the string S, and we know that that's 2, right? There's 2 O's in that string. But this method returns an integer type. And so we can't do method chaining on something like this because, it sort of broke the chain by being converted into an integer. I could convert, or I could chain some integer methods on top of this, but it can't chain, repeatedly call the same string method like I can do with replace. So using this principle, we are going to return genes.replace a 0, oops, and then just immediately replace the next thing. I'm going to run out of room here just because I'm zoomed in so far. And I have a syntax error because I used a colon. And I still have a syntax error because I was using colons everywhere. Yikes. All right. Hopefully you can remember that this, we have it right here. So 0, 0, 0, 1, 0, 0, 1, 0, 1, 1. Yeah, that looks good. So that's method chaining right there. We're just chaining a bunch of replace statements on top of each other. All right, so let's go ahead and copy that in to learn, just to show that we're passing tests and I'm not just showing you a bunch of nonsense. Right, so we're passing our tests. Here's that old iteration of our solution using if, else. So look at that. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 lines of code that we just replaced with a single line of code. And it looks like 2 because my editor word wrapped here, but you know, the entire solution is on line 2 right here. Okay, so I'm going to show another solution, and I'm getting into some more advanced topics here. You know, feel free to watch on, but don't get discouraged if you kind of get lost here. There's another method, another string method called join. All right, and so join takes just an iterable or a sequence of strings, and it joins them together using the join string, whatever this calling string is. This could be an X, and then it just join a sequence of strings with X's. I guess I can show that. I guess I can, let's see. Oop. All right, so it's taking a sequence of characters here and joining them with X's. So hopefully you're already familiar with that. Here's where things are about to get a little weird. I'm going to use an F statement and a comprehension. Char, engines, maybe just, yeah, char is fine. So what I'm going to do here is take the string ACTG, and notice its indices are 0, 1, 2, and 3. So I can take the indices of this string using the index method. So char is coming from genes. I'm going to call the index method on this string with the char that's coming from genes, and that's going to return either a 0, a 1, a 2, or a 3. Then I'm going to take this object and I'm going to use some string formatting to convert it to binary. So this piece right here is some string formatting syntax. This is saying pad this object with zeros so that it's a width 2. And then the B symbolizes that we're giving it an integer and we want it converted into binary for us. So this is a little kind of weird and messy, and maybe you haven't seen anything like this before. This inner expression is called a generator, and you can learn more about that when we release our advanced Python materials. But we're getting on to about 18 minutes runtime here, so I'm gonna kind of clean it up or finish it up here. So we have ACTG. We're going to index into this string to check which index char is. So if char is a C, ACTG is going to return 1, right? Because C is at the index 1. And then we're going to convert it into binary. So the index 0 is 0, 0. The index 1 is 0, 1. The index 2 for T is 1, 0. And the index 3 is 1, 1 for G, which is exactly the mapping that we need in order to make this translation. And if I run this code, we see the exact same output that we are expecting. All right, one last solution here. I'll leave that one up. So encode with join. So I'm going to use a string method called translate, which takes a mapping. It takes a mapping of characters to other characters. And you can call string.translate on some string. So I could say, you know, some string.translate and give it some translation T, some table of lookup values, and it'll translate this message character by character. And that's exactly what's happening here. We're taking this string of genetic data, character by character, and we are translating it using a known mapping that we came up with, which is 00 for A, 01 for C, and so on and so forth. So all we need to do, so return genes.translate T, where T is going to be some translation table that we need to come up with. And so the translate method takes a dictionary of a certain form, and we can create dictionaries using a zip, because zip returns tuples. And so the dictionary, when you pass a zip object to a dictionary constructor, it's going to unpack those tuples into key value pairs. Now I'm going to do something a little weird. So the keys are going to be the first elements in this zip object, which are coming from this map. So this is mapping the string function ord onto this string here. So this is going to return 65, 67, blah, blah, blah. This is I guess I can, if you're unfamiliar, ord. It gives you sort of the numeric representation of these characters. And then you can call char, which is another function. Whoops. Oh no. And you can get the character representation from the integer. Now, the reason I'm doing this is because translations specifically require numeric keys. And so, if this translation table sees an A, it's going to use its ordinal value, 65, to look into this translate table. And then, so the second thing the thing we're zipping with is going to be 00, oops, 01, I didn't mean to run my code, 10, and 11. Get rid of all that. Okay, there's a lot going on here. So map ord ACTG is returning essentially a list of the ordinals of each of these characters. I guess I can show this piece by piece. Oops. Cast it to a list so you can see. All right, so those are the ordinal values for A, C, T, and G. So those are going to be the first thing that we pass to zip, and then the second sequence is this thing right here. So if we cast this whole thing to a list, you can see here we have this zip object, which is pairing the ordinal 65, which represents capital A, to the substring, or to the string 00. And then 67, which is the ordinal value of C, gets mapped to 01. And then finally, I'm casting that to a dictionary. And that gives us this sort of key value mapping. All right, and so finally, what we can do is, well, we already have it written. So we have this translation dictionary, and then we can say genes.translate using this table T. I forgot to exit my interpreter. And code is, oh, right. And there we go. That's the final solution I wanted to show you, because we are at 24 minutes now. Sorry this went so long. Hopefully you probably already left. I'm just talking to my dog. But yeah, so just, a whole bunch of different ways to solve this challenge, and hopefully it's got your mind, kind of, churning, thinking about different ways to solve a challenge. right? Because we started with this very, very basic, very fundamental sort of core syntax from Python, which is, a for loop and some if, elif, else statements, and that's it. It was very bare bones, very, very basic. And again, nothing wrong with that. If that was your solution, that's totally fine. But hopefully this video will inspire you to start thinking about different ways to solve these challenges. And some of them are more optimal. This particular solution is actually pretty slow when compared to using a dictionary or using this translator. If we predefine this translator, then it's ready to go, and we can just call genes.translate on any gene sequence, and it's very fast. I won't get into some benchmarking here, but yeah. So hopefully this inspired you to start looking at maybe alternate ways to solve your challenges and not just move on after you've finished a challenge. The hope here is that you start looking for ways to, learn new tricks about the Python language, because as you can see, there's numerous ways to solve challenges, some of which are very cool, at least in my opinion. Okay, see you in the next video.